Good morning, everyone. My name is Brett Felton, and I'm the National Market Manager for Industrial at Graybar. I'd like to welcome you to Graybar's G2 Talk presentation on ensuring an accurate arc flash hazard analysis. This talk is a part of a webinar series we offer each month for our industrial customers. And we have a great discussion lined up for you today. But before we get started, I would like to cover a few housekeeping items. First of all, if you were one of the first 50 people who joined in on this presentation, you will receive a coupon for a free cup of coffee, courtesy of Graybar. Thank you very much for your time today. Also, at the bottom of your screen, you'll see a box for Q&A. Feel free to submit questions throughout the presentation. We'll address as many questions as time permits at the end of the presentation. And if we don't get to all the questions during this live session, we will reach back out to you after the presentation and make sure your question is addressed. So please, everyone, please make note of that Q&A box. We definitely want to make sure we are answering all your questions, provide all the information that you are looking for from this presentation. All right. Lastly, our G2 Talks are all archived on the graybar.com website. So you'll be able to view this presentation again at your leisure or recommend it to others. We're happy to team up today with Schneider Electric. As an electrical distributor, Graybar works alongside Schneider to provide customer support in areas like arc flash. And we can provide any needed safety PPE, safety tools, or additional electrical items needed for arc flash risk mitigation. At this time, I'm pleased to introduce today's speaker, Reza Tajali. Reza is an engineering manager at Schneider Electric Engineering Services. He has over 30 years of experience in the industry and holds 2 United States patents on switchgear products. In his present function, he manages a power system engineering team that supports industrial and commercial customers with power system design, analysis, and power quality improvement plans. So, without further ado, I would like to turn the presentation over to Reza. Reza, take it away.
All right, thank you, Brett. This is Reza Tajali, and I'd like to welcome everyone to the presentation today. We're going to be talking for about half an hour about arc flash, how to get the best out of this, how to get the most value out of this, and how to keep your employees safe the best you can. And then we're going to answer questions, as Brett indicated, so please forward the questions to us so that we could take them up at the end. So talking about arc flash, what is arc flash? It's basically an event which involves 2 conductors of electricity basically coming in contact with each other. And as a result of that, we'll have an arcing, and a lot of energy is released in the form of radiant energy and also in the form of an explosion that could take place. And basically you could throw the worker away from the equipment, pin him against the wall. And also there's molten metal, which is produced as a result of this process. It could be molten copper or aluminum, which is dangerous. So it's basically a dangerous event. It could be a fatal event. And there's been many of these happening. As a matter of fact, if you talk to any electrician who's been in the business for a while, they have invariably seen it. Every time that I've asked an electrician about, have you ever seen an arc flash in your life, generally the answer is yes. I've been either exposed to it or observed it. And the fact that that electrician is out there talking to me is an indication that a lot of these occur and people get away with it. But unfortunately, in some cases, it causes major damage and causes major issues and creates problems. So talking about results of arc flash, it causes personal injury. That's first and foremost what we are trying to avoid. We're trying to keep our people safe, all of us. But then it also has other business ramifications for the business. There's downtime that's associated with this because when the equipment fail and are subjected to an arc flash condition, then at that point electricity supply is cut off to the facility, and of course at that point in the facility there's lost production, there's lost revenue, there is lost reputation with the customer who doesn't receive that product. There is lost reputation due to the fact that the employees were not kept safe. There's issue to the morale of the employees. But there is an OSHA, Occupational Safety and Health Administration issue because OSHA frowns on these kinds of events and investigate it very thoroughly. And so there are regulatory impact associated with these. So there are many reasons why we want to avoid these arc flash incidents. And also when we get to a point of keeping workers safe, we like to see what we can do in the facility within the electrical power system to mitigate or reduce the effect of these arc flash accidents. So it's not just about what can we put on the worker to try to protect him instead of in terms of personal protective equipment. It's also an issue of what can we do in here to reduce the energy of arc flash, and we're going to talk about that topic during this presentation. So the purpose of an arc flash analysis is basically to calculate the arc flash energies and put them into a format of a label that would go on the equipment so that when the worker approaches the equipment, he has knowledge of what that danger, what that hazard is, and he can appropriately protect himself with wearing appropriate PPE. So this is, by the way, one of the last rungs of protection when you come down to hierarchy of protection for the worker, because we are at the point of PPE is basically the last resort of protection. Always there are tasks that could be performed ahead of this that could protect that worker. For example, taking safety considerations of putting the equipment in a safe condition to begin with, if possible, is the action the worker should be taking. But if the worker is performing a permitted activity on the equipment, what I mean by permitted is certain actions are allowed to be performed by National Fire Protection Association and OSHA. For example, task of troubleshooting on a piece of equipment typically cannot be performed if we shut down the equipment. So if the equipment is energized and the worker is performing troubleshooting tasks on it as it should be done, then in that case, that worker is subjected to that arc flash energy, and the task cannot be performed with equipment shut down. So in that case, we have to put the right PPE on that worker, and that is basically what we are talking about here. Is the output of this arc flash analysis would be an engineering calculation that would provide us with those energy levels that the worker will have to protect himself against. So what are the steps to compliance? Not just arc flash compliance, generally compliance to the National Fire Protection Association requirements and the Occupational Safety and Health Administration requirements. It's basically you have to start with an electrical safe work practices policy. So the policy of the company, it's really an EHS policy. This is the EHS department that establishes this. So it's a responsibility of the corporation to have a written policy that outlines what are the responsibilities of the facility owner and what are the responsibilities of the worker. So these need to be clearly defined. Procedures need to be written that establish how to approach electrical equipment, how to safely do what is allowed on them, and also procedures need to be established about training of the workers, how they need to be trained, what training they need to receive, on what kind of a criteria or selection, and all of these go into that safety policy. So if you don't have that safety policy, or if it's not up to date, if it hasn't been audited within the past 3 years, that's something that you would want to do now first, because the NFPA 70E standard requires the safety policy to also be audited on a schedule not to exceed every 3 years. Then we have to perform the arc flash hazard analysis or assessment, and then we have to label the equipment according to what we find. with this arc flash analysis. And that is the main topic of discussion today for what we're talking about, is how to do this part most efficiently, most effectively, and get the maximum benefit out of it. But recognize this is just one rung of the ladder. This is not all of it. So there may be a perception out there sometimes that, okay, we're just going to go ahead and put stickers or labels on equipment and we move on, we are done, we are in compliance. Well, it provides an appearance of compliance, but it's not really compliance for the reason that basically the way OSHA sees this, the general duty clause of OSHA mandates that the owner of the facility must protect his workers from any hazards that could unduly be that the employee could be unduly exposed to. So if there is an opportunity to reduce the hazards, the owner of the facility must take advantage of it. And that is not just a matter of putting labels on the equipment. And we're going to talk about that a little bit as we move on forward. So we have to have personal protective equipment available on site. The owner of the facility must provide that to the workers. There must be insulated tools provided to the workers who are going to be working on equipment that would potentially put them in a hazardous condition in respect to the electric shock or arc flash. And these items of clothing and tools need to be acquired and need to be provided. Then a safety training needs to be provided. This is basically a requirement in OSHA and in NFPA 70E that the workers must be qualified. And what is meant by qualified worker is a person who is familiar with the equipment that he is working on, and he is also familiar with all the safety procedures and processes that's laid out by OSHA and NFPA 70E. So that training essentially gets the worker through those items written in that electrical safe work practices policy and through some basics of safety protection, and that's typically done in an 8-hour class with somebody who has the knowledge and the experience to impart that knowledge to the worker. Best practice there is to have some supplier who has some record keeping and some means of documenting this training and providing you that document that it has been provided under what conditions, so that you have that available as record of what you have done. So safety training needs to be performed, and then we have maintenance and testing of equipment, because the electrical equipment will not function properly if they're not properly maintained. And what's going to happen is, if we have an arc flash occur somewhere in the power system and the circuit breaker that's feeding this that circuit, that's where there's an arc flash occurring in, if that circuit breaker is not properly set or is not properly adjusted or maintained, there's a possibility that breaker will not trip, and or not trip within the time frame that it needs to trip, and that malfunctioning of the circuit breaker could significantly increase the amount of energy downstream. So in other words, the worker could go to the equipment, read on the label certain amount of energy, try to protect himself with the appropriate clothing, and then find out if an event occurs that he's subjected to a significantly more energy. And that is not a good condition. So that could happen if equipment are not properly maintained. So maintenance of the facility's electrical system is a must, is referenced in NFPA 70E. In fact, an entire chapter is dedicated to maintenance of equipment, which indicates how important this subject is and how seriously it is taken by the writers of the NFPA 70E. And then last step of this, we talked about mitigation and control of the arc flash hazard. And in this step, what we're talking about is the fact that whatever we calculate on a piece of equipment and we write on that equipment as a label, that level of energy may not be practical for the worker, in the sense that if we have a motor control center, for example, where the worker has to perform the troubleshooting actions on the motor starters, and when he approaches this piece of equipment, he has to work on it energized, because that's the only way he can troubleshoot. So it complies with the basic requirements that he is allowed to perform this troubleshooting with the equipment energized. When he approaches it, if this equipment is, let's say, category 4, that is not a suitable working environment for that worker. because to get into a Category 4 clothing suit, that's too cumbersome, it's too heavy, it reduces his dexterity and his capability, his motion quite a bit, it reduces his eyesight due to the shielding that's used on the equipment. And all of that basically could cause the worker to try to rush doing the task, or also another issue with the heavy clothing is that they're hot in the summer. If you're working in them, you can't really work on them in more than half an hour. You have to take them off after a while. So in general, for that worker trying to work on that motor control center Category 4 is just not practical. And what has to be done, some engineering evaluation needs to be done to see how we can reduce that energy level on that piece of equipment so that it's at a level where the worker can work on it with the right amount of PPE. And this is a subject of mitigation. It's a very important subject, and it has to be recognized that part of the general duty clause in OSHA, where it requires the owner of the facility to provide a facility that's safe and free from hazards that could potentially injure or kill his workers, then when you look at that, that extends to the fact that just putting a label on the equipment and then requiring people to wear tremendous amount of clothing and do tasks that are not associated with that, that would not fly, basically. So some mitigation has to be performed, energy levels have to be reduced. And that is the last step of this that pertains to the arc flash analysis. So we're going to elaborate on this a little bit. In performing the analysis itself, the first thing to be conscious of is the single line diagram. So if you call a supplier to provide you with an arc flash analysis, it would be good to look into your records and see if you have single line diagrams available. If they're available, what is their condition? Are they accurate? Have they been updated? Did you have an addition that wasn't included in the single line? Those are good things to know and tell the supplier so that the supplier knows the amount of effort they're going to have to put into this in the field for collecting the data. A single line simplifies the data collection quite a bit. If we don't have a single line, we have to basically create one. And the process of creating one requires to go ahead and basically find out, trace the circuits sometimes or follow the circuits and find what feeds what. And that kind of an action is very time-consuming quite often to be done. So single line is the key and most important element. Also, a single line is used in the process of lockout-tagout, so it's a very important safety item. The data that we need for performing these arc flash analysis include conductor and cable sizes, lengths, and protective device characteristics like circuit breaker, set points, fuse sizes and types, and relay settings. These kinds of equipment data need to be collected in the field. And this sometimes to perform this data collection, we quite often have to open equipment. We may have to take the covers off of the equipment and obtain the data. So it's very important when you are assigning this task, giving it to somebody to do for you, to make sure that they're properly qualified workers deployed to the job site, because the task itself could be hazardous when people are exposing energized parts in order to write down the data. They're not working on any equipment. However, still exposing energized parts requires them to be trained and qualified to perform the task. So that's one item to be careful about as far as your specification is the qualification of the supplier to make sure that they have, you could look at their safety record. You can require to see their safety record, see if they have had accidents, if they have injuries. How do they treat safety basically themselves, and use that as a guideline there. And then the other item pertaining to accuracy of data collection is the fact that invariably when we are performing this analysis, there's a bit of an art involved with them. There's a certain amount of science, but there's some art. A certain amount of assumptions invariably are made in any study being performed. So what we do in our group, we deploy our engineers to lead the data collection team. So we never just send a bunch of technicians to go collect the data. And the reason for that is because of what I just mentioned. There is judgment that needs to be applied to the process. This is not just a rote procedure of collecting data, putting them into computer, and then pushing the button. If that approach is taken, unfortunately, the result is not what you really want to have. Invariably, you have to use judgment in this. We could talk about that some more, but in this particular presentation today, there's not much time to get into the detail of electrical engineering that goes into this. Suffices to say that the right way of doing this is to make sure, preferably actually that professional engineer who is going to be ultimately responsible for signing and stamping the work to be on the site and lead the activity, lead the people. Or second best is to have another professional engineer or somebody who is qualified for arc flash analysis to be on the site leading the activity. That way you make sure that any assumptions are made, any judgments that are used are appropriate judgments and are going to provide the right data for you. So moving on, basically, the next issue that you have to be concerned about dealing with arc flash analysis is the fact that the data that's coming in, if it's not accurate data, it will basically provide wrong data, wrong answers to you. So we have a kind of a garbage in, garbage out situation, and the result of that, if the study is not performed correctly with accurate data, is the fact that we could have too much PPE on the person or too little PPE on the person. And having too much PPE basically has the hazard in there of the worker not being able to see properly, not being able to act properly, not being able to move properly, and this could be a very hazardous condition because he could rush during the task. The PPE equipment, especially the higher levels like Category 3 and 4, are very heavy, and it could cause the worker to basically sweat and have issues, especially in summertime. So this heavy equipment should not be worn more than half an hour. People need to get out of them. And also, if there is not sufficient amount of PPE on the worker, it would create a different situation where the worker is insufficiently protected, and in that case, then he could naturally burn and be injured severely if an arc flash incident were to occur. So both of these situations are undesirable. We don't want to have too much PPE. We don't want to have too little PPE. Both of them are dangerous and create hazards for the worker. And you need to be careful about that issue, that going on the conservative side automatically, making assumptions or making judgments, engineering judgments that lead on the conservative side, in this case is not necessarily the appropriate action to do. We have to it's a balancing act where we need to optimize the arc flash analysis to a point where we don't put too much PPE on the worker or too little PPE on the worker. So what are once the calculations are done, what do we do? Workers are required to wear these flame-resistant equipment and personal protective equipment that's provided to them, and they have to, that's basically the responsibility of the worker to comply with the requirements. He has to be trained and know how to comply with the requirements. He has to be told what he needs to be wearing. He needs to be qualified to perform a hazard assessment, a risk assessment on the equipment, and all of these are requirements of the worker to be trained with, but then he has to follow that rule. He has to follow essentially the electrical safe work practices of the company, and then what the worker wears depends on the incident energy level that's been calculated, of course, and also the specific task is a consideration because then at that point we're looking at, like for example, what we were talking about here was the worker working on a motor control center, a task that he considered to be something that he's allowed to do because it was a troubleshooting action that could not be performed with the equipment de-energized. However, if that action could be performed with the equipment de-energized, he should de-energize equipment. So he has to be concerned about the task, and he has to be concerned about the energy level that he's going to be dealing with. So what are the components of a good study? Here is where we're talking about where do you get the maximum benefit out of the money that you're going to spend on this and out of all the efforts that you're going to put into this task. First of all, there has to be a good one-line diagram produced. If one is not available, one needs to be created and produced. It should include the switching configurations because the configuration, the way that the sources of supply are connected to the power system impacts the result, the arc flash that's resulting from the analysis. So switching is very important. It's one of the considerations that have to be made. And again, that's one of the items that, as I mentioned in the beginning, it's important to have the engineer on site when the data is being collected because you want to have engineer involved in all the judgmental issues that get involved and have his own first-hand exposure to the data collection process to know what needs to be done based for making these assumptions. And then accurate system data needs to be properly documented, electrical apparatus, impedance data in the system, like cables, transformers, and so on, and overcurrent protective devices have to be accurately, the data have to be accurately collected. You don't want this part to be shortcut and people taking ways and means of reducing the effort here by making unnecessary assumptions. So it's important the data is accurately and meticulously collected from the power system. And then a complete report needs to be generated. We recommend to people to also perform a short circuit study on the system. Short circuit study basically evaluates the equipment for the short circuit rating to make sure they're appropriately rated. And a time current coordination study is absolutely necessary here because with the time current coordination study is how we establish what the settings on the devices should be. And if we just go ahead and collect the data, run the study, calculate arc flash energies, and then label the equipment and walk off the facility, we've done the facility a bit of disservice in the sense that we haven't done everything we can on evaluating what can be done to reduce the energies. And this coordination study is where we really start evaluating the settings on the devices to see how we could possibly reduce the arc flash energies in the system. And it's a very important component of the overall evaluation. And you have to make sure these are specification items that if you don't specify a short circuit study to be performed, it doesn't automatically get done. It's something that needs to be specifically stated that you want this. And the short circuit study is different from an arc flash study because in a short circuit study we evaluate whether the equipment is rated properly for the short circuit currents. That's different from calculating the incident energy level, the amount of radiant energy that would be generated from an arcing fault, which is an arc flash study. So we recommend to you to have in your specification a short circuit study, a coordination study, and also the arc flash study as we discussed in here, and make sure that the supplier is going to evaluate device settings to see what compromises need to be made in order to reduce the arc flash energies, and also see if the supplier would recommend to you some solutions to reduce the arc flash energies in those places where the level of energy makes it impractical for the worker to perform their tasks. So this is, again, a judgment needs to be made, and again, that's another reason why you would want to have that professional engineer come to the site and be involved in the data collection process. You don't want him to be isolated from it and just basically sitting in the office trying to do it in isolation. So when you're looking for an analysis provider, what are some of the things you want to look for? Make sure they're licensed in the proper state as a professional engineer. If you have multiple facilities, then you want to work with one supplier. Make sure they have professional engineers in each one of those states. where the work needs to be performed. The task being performed here is an electrical engineering task, and individual states require that people performing electrical engineering being properly licensed when they offer that service as a service. So proper PE registration is a requirement of the state. It also basically verifies the fact that the study that you have got performed on your facility, it's complied with the state requirements as far as registration. Make sure the engineering firm that you're using for performing the work is a registered firm. The individual states in the United States, they require the firms to be registered in addition to the individuals being registered. So make sure you're talking and working with a registered firm. A firm that's registered in Tennessee does not mean that it could operate in Alabama. In fact, they can't. You have to be a registered firm in Alabama in order to operate in Alabama. And same thing true about the other states. And do not allow subcontracting. What I mean by subcontracting is a practice of somebody trying to take an arc flash study, and then go ahead and hire somebody else to just go get the study and bring it to him. This kind of stuff is where causes problems in data communication, and that's not a very good thing to do. Write down in your specification, you do not allow any subcontracting. The firm that takes on the work has to do the work and finish the work. And then you have assurance that whoever is taking charge of this study, from the beginning of it, he's involved with the data collection, he's supervised it personally, and then he produces the result for you. So then there's several items in here about the knowledge and expertise of the company doing the work. You can expect and demand them to have several years of experience doing this kind of work. You can have them show you that they have worked in your kind of industry. Industries are different. You don't want just anybody coming into your plant and start tinkering with the equipment. You want to make sure people coming in there understand your process, and don't go around shutting things down or creating accidental hazards in your facility while they're performing this data collection task. You want to make sure there's a standardized reporting, especially if you're a corporation who has multiple facilities around the country. You don't want to do a study in Arizona and then do a study in Oklahoma and come up with two entirely different sets of results. And not only does that create an issue for your company from an enforcement standpoint and the general EHS standpoint, it also creates a situation where you cannot really be applying two sets of standards to two different plants. That just doesn't make sense fundamentally from a safety standpoint. Have to be careful with that. So you could demand standardized reporting, national coverage of the company if you are of the kind of corporation who has multiple facilities. And finally, and most importantly, make sure that the supplier makes recommendations for corrective actions to reduce arc flash energies where the energies are high enough that make safe performance of safe allowed work on that equipment to be impossible. So look for those factors. They're important. Of course, naturally, taking on the lowest bid is probably not the best approach that you can do for the safety of your worker, but also from the standpoint of protection for your corporation. So at this point in time, I give it back to Brett to bring up some of the questions that has been received, and we'll try to answer them.
Thank you, Reza. That was an excellent presentation. At this time, we would like to address some questions that have been submitted. As a reminder, you can submit a question using the Q&A box at the bottom of your screen. And again, if we don't get to your question in the time allowed, we will follow up with you after the presentation. Okay? All right, Reza, I've got quite a few that have come in here, and a number of members in the audience asked this question first. How often are the arc flash studies required to be performed?
That's a good question. Well, first of all, if you have not done a study yet, it needs to be performed. That's no question about that. But then after that, every time that you make a change in your power system, you have to be conscious of the arc flash energy levels. Like, for example, let's say you go ahead and you've got a facility that's been operating under certain conditions, supplied from a utility company with a 1500 kVA transformer. And then utility company comes up and the transformer, utility company blows up, utility comes up, changes the transformer. They change your service, put a 2500 kVA transformer there instead of a 1500 kVA. Well, right now, every calculation done in the facility has basically got shot because the short circuit currents went up by quite considerably due to change in transformer. So a short circuit study needs to be reevaluated anyway, and the arc flash energy is changed. So it's advisable, actually required by the standard, that anytime a change occurs in the system, a consideration be given to arc flash analysis. And of course, it depends on the change that is being performed, how major that change is. Also, even if you do not make any change in your system, every 5 years an arc flash analysis has to be redone, has to be reevaluated to account for changes that invariably take place. For one thing, for example, utilities, their available fault current is constantly changing, and that is a factor that needs to be considered.
All right, thank you very much, Reza. We have another question from a member of the audience. They're basically asking, so is the general duty clause the only true reference to arc flash within the OSHA standard, or is this truly an OSHA required item?
That's a very good question. The general duty clause is what quite often people refer to, and it is fundamentally says that the owner of the facility shall provide a safe environment for his worker, in a simplified paraphrase statement. Or on the other side, looking at it negatively, it should not expose the worker to undue hazards or hazards that cause him injury and hazard and loss of life and so on. So that when you start trying to comply with that, then you say, well, okay, we know that we have a hazard here, an arc flash hazard. It's a real hazard. It does kill people. So therefore, we have to protect workers against it. How do we do it? And if you know that you have an arc flash hazard, well, the way to do it would be to perform an analysis and properly protect the worker. Now, also OSHA standards, it requires that specifically requires that workers must be provided and wear appropriate PPE for the task being performed. So that general statement, which is separate from the general duty clause, requires PPE to be worn. Now, if you have to wear PPE, what PPE do you wear? OSHA doesn't specify that, and basically leaves that to consensus standards in the industry. In this case, it becomes NFPA 70E by default. So then we look into NFPA 70E to give us the answer as to what the workers have to wear. So that statement of OSHA about requiring the PPE is about as close as we get to requiring an arc flash analysis.
Okay, thank you. Thanks again. Okay, another question from the audience. I have had a recent arc flash study completed by a local engineering company. Can Graybar and Schneider still help? Does the original manufacturer need to provide the mitigation recommendations?
Very good question. So in this case, a study is already done, and I assume that when that study was done, the supplier of the study did not provide any mitigation. In other words, they did not evaluate how to reduce arc flash energies at points where it's too high for the worker to work on the equipment. Now, if that happened, then yes, definitely Graybar can help, and Schneider Electric can help. We can look at that study and evaluate, depending on the condition of that study, we may be able to help with the mitigation part of it directly, or we can evaluate that and see if we see some other concerns about this study, we will bring it up to the owner's attention. It really is going to vary quite a bit from case to case. There's not a general rule in here. But yes, the general answer to that question is yes, there's possibility that we could help you. In that case, take a look at that study and do some evaluation on it to see in what way we can assist.
And you're right. If that analysis was done, the report was done, then It depends on what recommendations are there to mitigate the risk. So you're right. Graybar and Schneider Electric can help with the modifications to electrical equipment, any additional electrical equipment needed to mitigate the risk. Again, the safety PPE required, the signage required around the area. Those are the kind of things that Graybar can assist in getting done for you.
Yes, very well.
Okay. We've got some very good questions rolling in here. Okay, sorry about that. Let me find the one I had planned to ask next. Is there a minimum standard for guarding around electrical panels? If workers are working in a panel, the use of safety cones can be used to block off the area, but what would the correct distance be to put those safety cones to keep the workers safe?
That's a very good question. Basically, so what we have here, I assumed that the equipment has been opened up. Somebody's removed covers off of the switchboard, for example, and the switchboard is energized. Switchboard being energized, of course, it becomes a hazard. There are two hazards in there. There's a shock hazard and there's an arc flash hazard. Now, we have a so-called arc flash boundary, which means that an area, basically a circumference around the equipment. So if the equipment is at the center and we draw a circle around it at a certain radius, and that distance of that radius basically being the arc flash boundary, at which point it would be unsafe to enter. So that if you want to put cones or you want to put cordon the area off or isolate it basically such that persons walking around who are not qualified, you want to make sure that it's placed at least at the arc flash boundary, which is a piece of information that would normally be on the arc flash labels. So that is from an arc flash standpoint. Then we also have a shock and electrocution hazard associated with this. So there would be a boundary in there associated with that. Now, one of these two boundaries is going to be a longer distance. So whichever one is bigger, that's the one that you have to use. Usually it's the arc flash boundary. So typically when you look on the labels, you're going to see boundaries associated with shock and electrocution. Yeah, there are distances that unqualified workers have to maintain. And then you're going to see a boundary associated with arc flash. And you take the bigger one of those two, and you put all the cones and cordons and whatever it is at that location so that, for example, janitorial people performing janitorial tasks and so on, or anybody that is not a qualified worker, does not have proper PPE, does not enter that space.
All right. Thank you. Great, Reza. All right. Another question here. This is about the power transformer for a facility. Does the arc flash analysis encompass also the primary side, the medium voltage, of the power transformer for a facility, and not only the low voltage side? Is that correct?
Well, that's a good question. And the answer to that question is it depends if the primary side of the transformer is under the ownership of the facility owner. So if you buy your power at medium voltage from the utility company, naturally that high voltage side of that transformer needs to be included in the evaluation and in the study. If you buy your power at 480 volt from the utility company, then in that case, you don't really need that information for the high voltage side. In fact, the high voltage side then becomes under the purview of the utility company, and their requirements, they follow National Electrical Safety Code. They are not, and they do have OSHA requirements for utility workers, but there are different requirements. So on that side of it, if it's the utility equipment and owned by the utility, it's basically covered by utility standards and their requirements, and typically facility owner would not be concerned with that. But if you own the medium voltage equipment yourself, that's definitely something to include in the arc flash analysis. Make sure your supplier is calculating arc flash energies there.
All right. Reza, just a couple more here due to time. As a plant owner, a plant manager, what is my responsibility for auditing my electrical workers' compliance with our safety plan and practices?
That's a very good question. Essentially, the plant, whoever has the ultimate responsibility for the safety of the workers in that facility, in this case the plant manager, needs to make sure that proper policies are laid out. Now we say that that safety policy is what lays out the policy. Make sure that policy first of all exists. And then secondly, that policy needs to be evaluated and audited on a 3-year cycle. How do we audit it? We go audit the workers. We go look at the workers working, and if the workers are complying with the requirements set in the company's own safety policy and the NFPA 70E and OSHA standards, then good. That's a good thing. If we see any variations or we see any issues there, 2 things have to happen. The workers have to be trained, properly trained to make sure that that issue is resolved. But then the policy itself needs to be reevaluated, because the way that the NFPA 70E is written, it says that you basically audit the worker, and from that you evaluate if they're following the policy. If they're not following the policy, you find out what is in the policy. What about the policy needs to be revised or corrected or evaluated? Is there some language in it people don't understand, or is there some shortcomings that need to be corrected? So once every 3 years, the policy itself needs to be audited. Now, the workers, the regulations basically require for the work to be evaluated by their supervision at least once a year. So a minimum once a year, I have to observe that worker and see how he's working at least at that rate. And then it's probably best for you to document that audit that you perform on the worker, so that you have a documentation that you have audited the worker, you've observed him working, and you've observed him in compliance with the requirements and so on. And again, if you find out there is something that he's not in compliance, then you have to provide the proper training. And all of these, by the way, they are spelled out in the NFPA 70E. There are a requirement there. So they need to be done.
All right. Thanks, Reza. And actually, the audience member who asked that had a second part to the question. Same thing. What is the plant owner's responsibility for contractors who are doing work on site?
Good question. As the owner of the facility, you have ultimate responsibility for the safety of anybody who walks in your facility. And if it's a contractor who comes in, you have the responsibility of showing him and telling him any hazards in your facility, including electrical hazards. So the calculations for arc flash, for example, need to be performed. Labels need to be there so that the contractor knows what level of PPE he's going to have to wear to protect himself. So the fact that we are hiring contractors to come into the facility and perform work doesn't absolve the owner from the responsibility of knowing what the hazards are and informing the contractor properly, and also even watching over that contractor what he's doing. And if you see that any violation of the safety requirements, you're required to report it to the contractor's management and take action. So this is there's wording again in NFPA 70E that covers this issue. So it's really important to recognize the owner's responsibility does not end when they hire contractors.
And does that apply to the contractor's PPE as well? Does the contractor provide their own, or does the plant?
The contractor provides their own PPE. The contractor provides PPE for his workers. So it's the responsibility of the contractor to provide PPE to his own workers. The plant's responsibility is to make sure that the contractor is doing that. And they do have their own safety practices, and they're not just there working without a safety procedure or without knowledge of basic safety requirements. That responsibility doesn't transfer away from the owner of the facility just because they hired contractors.
All right. Reza, thank you very much for fielding those questions. For all the folks in the audience, we are running up to our time point on this. I apologize if we did not address your questions live, during this presentation. But again, a Graybar representative will reach back out to you and answer your questions that you submitted. I did notice that a few folks asked who should they talk to about getting an analysis done, and I would advise you to reach out to your local Graybar branch. If you know your Graybar representative, they can help get an arc flash analysis done for you by Schneider Electric Services. And again, we will make sure that a Graybar representative responds to any of you that asked about that during this presentation. Okay? One more reminder, this presentation will be archived on the graybar.com website. So please allow a day or two for it to be uploaded, but go back to www.graybar.com and look for the section on the homepage for G2 Talk webinars, and you will be able to find the title of this presentation in the series, and then be able to view the recording at that point. But please allow a few days for that to be uploaded. And again, I want to thank everybody in the audience for their time today. I want to thank Reza for the presentation as well, and his time with this whole group. And again, to everybody, I hope that you join us again next month. Next month we'll have another G2 Talk webinar for industrial customers. And next month we'll specifically be talking about machine safety applications and standards. So again, look to www.graybar.com and the G2 Talk webinar section of the homepage. In the next couple of days, we'll get that announcement out there so you can register for that G2 Talk webinar as well. Thank you, everybody. Hope you have a good day, and thank you again for joining us for this presentation on Arc Flash.